Hello friends, most welcome in this informative video of Career Convent YouTube channel. In this video, we are going to explore the vacuum impregnation technique, a highly effective process used across industries to seal porosity and improve the reliability of critical components. Let's dive into the fascinating process. Vacuum impregnation is a key process in manufacturing and engineering, especially where components must be pressure tight and leak proof. It's commonly used in automotive, aerospace, and electronics industries, where quality, performance, and reliability are paramount. In this video, we will cover the principles, process, benefits, applications, and key considerations of this technique. So question is, what is vacuum impregnation? Basically, it's a method used to seal microscopic voids or porosity found in metal and non-metal components. These tiny voids are usually the result of casting, sintering, or molding. If left untreated, they can lead to leaks, corrosion, or even mechanical failure. The process involves removing air from the pores using vacuum, filling them with a special sealant, and then curing it without altering the shape or properties of the component. Vacuum impregnation plant. The process is carried out in a vacuum impregnation plant, also known as VPI chamber. These plants improve material performance by injecting a liquid resin or sealant into the voids under vacuum pressure. So question is, why is porosity a problem? See, even if it is not visual, porosity can cause leaks of fluids or gases, reduce mechanical strength, poor surface finishes, machining issues, corrosion starting points, and in electronics, reduce dielectric performance. You must know here what is dielectric. Actually, they are materials that store electrical energy rather than conduct it. Example includes ceramics, plastics, mica, glasses, distilled water, transformer oil, and even gases like nitrogen and helium. So how vacuum impregnation works? Let's break down the process. Number one, pre-cleaning. First, the part is thoroughly cleaned to remove oil, dirt, or machine residue. Number two, vacuum stage. Next, vacuum is applied to evacuate air from the component's void. Number three, impregnation. A liquid sealant is introduced, filling all the porous spaces. Number four, drain and rinse. The part is rinsed to remove any excess sealant from unwanted areas. Finally, the sealant inside the voids is hardened either using heat, UV light, or other curing methods. Type of sealants used. Various type of sealants are used depending on the applications as thermostatic resin. Thermostatic resin like epoxy and polyester. These are heat or UV cured. Anaerobic resins. They cure in the absence of air, great for tight voids. Silicates. These are water-based sealants used in ceramic components. Acrylic resins, popular in automotive and aerospace for their chemical resistance. Application of vacuum impregnation. Where is this technique applied? In automotive. The process is used in engine blocks, gearboxes, and almost all type of aluminum parts because they are prone to leakage due to pinholes and blowholes. If we talk about aerospace, this process is used in hydraulic components and fuel systems. Talking about electronics, this process is used in electrical connectors and transformers. Sintered parts, this process is used in bearing and filters. In 3D printing, this process is used to seal internal porosity in metal printed parts. Benefits of vacuum impregnation. This process offers several advantages: prevent leaks, improve machinability, enhance corrosion resistance, maintains dimensional integrity, gives a better finish for plating and painting, and overall, it's a cost-efficient quality control method. Limitations and considerations. But like any process, it has its own limitations as number one, the part must be properly cleaned. Number two, the sealant must be suitable for material and applications. Number three, not ideal for extremely large porous parts. And number four, curing must be precisely controlled to avoid damage. Standards and best practices. Several industry standards govern this process as MIL I-17563C. It's a US military standard which governs this process. ISO 16378 aerospace grade standard also governs this process, and ASTM B783. This gives the guidelines for sealant performance. Recent advancement. Some recent innovations include as automated system being used for high volume production. Eco-friendly sealants have been introduced in market. Those have low VOC emissions. Industry 4.0 integration has been done for this process. Many industries are using hybrid vacuum pressure system for better penetration. Conclusion. To wrap it up, vacuum impregnation is a precise, reliable technique that significantly improve the durability and quality of components. From automobile to aerospace, from sintered metals to 3D printed parts, this process helps industries in prevent failure, reduce rework, and deliver superior products. Thanks for watching my video and don't forget to like, share and subscribe for more technical insights. Thank you and bye bye.